Contrary to popular belief, Sir Isaac Newton was not a determinist who believed in a clockwork universe. As Ted Davis stated in 1991, in fact, Newton rejected both the clockwork metaphor itself and the cold mechanical universe upon which it is based. His conception of the world reflects rather a deep commitment to the constant activity of the divine will, unencumbered by the rational restrictions that Descartes and Leibniz placed on God, the very sorts of restrictions that later appealed to the deists of the 18th century. And while Newton's belief in the divine will of God sustaining the universe is good as far as that goes, it is interesting to note where Newton's belief in divine will got him into theological trouble. Newton grappled with perturbation theory, the idea that the gravitational forces between planets could destabilize the solar system, potentially flinging Earth out into the cold void of space. To resolve this cosmic conundrum, Newton put forth an idea. God, in his divine wisdom, might occasionally reform the planets. A passing comet, for instance, could be used by the divine craftsman to nudge a planet back onto its intended path. This was a universe that, while largely predictable, required occasional divine adjustments to maintain its harmonious order. Newton's views, therefore, invoked divine intervention to explain the stability of our solar system. Gottfried Wilhelm Leibniz, a contemporary of Newton, had a different perspective. He argued, when God works miracles, he does it not to meet the needs of nature, but the needs of grace. Leibniz took issue with Newton's idea that God would need to continually correct the course of the planets. He believed that if God had to remedy the defects of his creation, it was surely demeaning to his craftsmanship. In Leibniz's view, a perfect creator would create a perfect universe that operates according to natural laws without requiring divine intervention to maintain order. The notion that God would need to send a comet to correct the planet's orbits, as Newton suggested, was not consistent with Leibniz's understanding of a powerful and wise deity. To repeat Leibniz's criticism of Newton when God works miracles, he does it not to meet the needs of nature, but the needs of grace. Anyone who thinks differently must have a very mean notion of the wisdom and power of God. Leibniz, therefore, rejected Newton's notion of divine intervention, arguing instead for a universe that functioned without the need for God's regular interference. Pierre-Simon Laplace, another great mind in the world of science, sided with Leibniz, citing his criticism of Newton's invocation of divine intervention. Laplace, a French scholar, saw the universe as a grand machine operating according to fixed laws. He considered, contrary to popular folklore, not God as an unnecessary hypothesis, but instead, Laplace considered the idea of divine intervention at a specific point as an unnecessary hypothesis that was not required. As Wikipedia states, it was not God that Laplace had treated as a hypothesis, but merely his intervention at a determinate point. Laplace believed in a deterministic universe where the past, present, and future are all predetermined by the initial conditions of the universe and the unchanging laws of physics. This view, often referred to as Laplacian determinism, argues that if we knew the positions and velocities of all particles at one time, we could predict their positions and velocities at any other time. In this perspective, there's no room for divine intervention to correct or adjust the course of the planets. The universe, according to Laplace, was a self-regulating entity, operating without the need for regular divine adjustments. Fast forward to the 21st century, and the question remains, is the solar system stable? Well, first off, Laplace's determinism has now been falsified by quantum mechanics. As Michael Egnor noted, researchers using Bell's theoretical insight into quantum entanglement have shown that there are no deterministic local hidden variables. This means that the final state of entangled quantum particles is not determined by any variables in the initial state. It is a scientific fact that determinism in nature as commonly understood is simply not true. Moreover, the closing of the freedom of choice loophole in quantum mechanics by Anton Zeilinger and company also falsifies determinism in that free will and determinism are mutually exclusive. In fact, with the closing of the freedom of choice loophole, it can now be forcefully argued that Newton's belief that God sustains this universe by his divine will has now been experimentally validated. As interesting as that is, let's get back to the question, is the solar system stable? Modern science suggests an exceedingly delicate balance for our solar system. Let's delve into the findings of renowned scientists Richard Webb, Scott Tremaine, and Hugh Ross to understand the intricacies of our cosmic neighborhood. Webb in 2009 explored the delicate architecture of our solar system. He stated, "You might also think that these disparate bodies are scattered across the solar system without rhyme or reason. But move any piece of the solar system today, or try to add anything more, and the whole construction would be thrown fatally out of kilter." So how exactly did this delicate architecture come to be? Imagine a celestial house of cards, where removing or shifting a single card could bring the whole structure tumbling down. That's the level of precision we're dealing with here. Just 2 years later, Tremaine further highlighted the unpredictability of the solar system over extensive periods. His metaphor of shifting a pencil on your desk today, potentially altering Jupiter's position a billion years from now, encapsulates the sensitivity of our cosmic environment. This unpredictability, he notes, is ironic given the deterministic principles that Laplace championed. And then we have Hugh Ross in 2017, who underscored the fine-tuning necessary for life on Earth. Ross, citing Brazilian and Canadian astronomers, demonstrated that even the slightest adjustments in the orbits of planets could spell disaster for life as we know it. Even tiny adjustments in the orbits of Jupiter, Saturn, Uranus, and Neptune would prove catastrophic for life on Earth since it destabilizes our orbit. Likewise, the orbits of Venus, Earth, and Mars must also be precisely calibrated to prevent damaging resonances. Similarly, the Earth-Moon system is crucial in maintaining stability in the inner solar system. It's a cosmic ballet of precision and balance, where every celestial body has a role to play in maintaining stable orbits. So what does this mean for the debate between Newton, Leibniz, and Laplace? It's clear that while the solar system might not require divine intervention to maintain its order, as Newton had originally envisioned it, its intricate design and delicate balance can very well be seen as a testament to the wisdom and power of a creator in creating the stable solar system in the first place. In the light of these findings, it seems that both Newton and Leibniz, and even the often misquoted Laplace, would all be very pleased with what modern science has now revealed about the wisdom and power of God in creating this precisely balanced solar system.